Hello everyone and welcome to Growing 5.2. Our learning targets for 5.2 is I will be able to explore and develop the rules of exponents. We're going to be looking at quite a few rules of exponents. We've already gone over a couple of them, but one of them is this up here, the a to the 0 power equals 1, meaning any integer raised to the 0 power is going to equal 1. Also, for all of this, we are going to assume that a is not equal to 0, that a itself is not equal to 0 for any of these exponent rules and properties that we're going to be going over. Down here at the bottom, I tell you that we will plan on filling the rules in on the bottom of the rubric. I already gave that to you. That is this with our homework, and down at the bottom, we have these different rules that we're and properties that we're going to go through on the videos, and we'll go through more of them in class. But I'm going to skip forward because there's a lot to go over here and I don't want the video to go too long. 5.2, the ACES questions 2 through 25 and 70 through 71. Page 78 and 79 in your textbook. You can read through this top part. I'm not going to read it to you today. I'm going to get right to the rules and start working through those. In problem 5.2, part A, we'll go with question 1A. It says, write each of the following in expanded form, then write the answer in exponential form with a single base and power. So I will go ahead and do part A for you as an example. So if we take 2 to the third and we write that out in expanded form, we have 2 times 2 times 2, and then we also have times 2 to the second. Well, times, it's the same as a dot or an X, so I can just put this, oops, it's supposed to be a dot, big dot, 2 times 2, and that takes our 2 there. So what do we really have here? Well, now we have 1, 2, 3, 4, 5 2's. So we can write it in exponential form as 2 to the 5th. So what we did here is, because we had the same base of 2 for each of these, our first rule is that if we have the same base, we can, and we're multiplying the two numbers together, we can take our exponents, our exponent for each one, and just add them together. So when we see 2 to the third times 2 to the second, 2 to the third times 2 to the second, what we can do is say that that is equal to 2 to the 3 plus, get things out of my way here, 3 plus 2, or as we found out, 2 to the 5th. Okay, so that's our first rule, and need to be able to show that down here in your final equation. Let's move to our second rule. Rewrite each multiplication sentence as an equivalent division sentence. So we're going to show this dividing. So again, I will take a look at A for you. I'm going to do it, I'll do it over here. We have 3 to the third times 3 to the second equals 3 to the 5th. Well, we just learned that if we have the same base, we're just going to add together these two exponents and wind up with 3 to the 5th. But let's say we had 3 to the 5th divided by 3 to the third. Okay, divided by 3 to the third. Well, now what we're going to do when we're dividing with the same base, we're going to subtract the exponents from each other. So we would have 3 to the 5th minus the third. Okay, and that's going to equal 3 to the second, which is what we have right here. Okay, we took 3 to the 5th, subtracted 3 to the third, we were left with 3 to the second. We'd actually divided by 3 to the third, but we're subtracting the exponents. That's our second rule that we're going to be working with here. Part C, write each of the following in expanded form, then write the result in exponential form with a single base and power. So again, I'll take part A. So expanded form, we have 2 times 2 times 2, because we have 2 to the third. And then times, again, we talked about the x for times, or the dot. We have 5 times 5 times 5. Well, in multiplication, we can reorder these however we want. So what if we did 2 times 5 times 2 times 5 times 2 times 5? Okay, I just reordered these. There's 3 2's and 3 5's still. Well, 2 times 5 is what? 10. So we'll take 10 times 2 times 5 is 10, times 2 times 5 is 10. Well, that winds up being 10 to the third power. And what we did here is, because we had the same exponents, we then and we had different bases, we then multiplied the bases together. We took 2 times 5, well, 2 times 5 is 10. And we kept our power that we had in both of them, which is being raised to the third. I'm going to pause this here so I can start the second file video for the website. Okay. Gone through the first 3 rules with A, B, and C, and now we are going to jump over here to part D. At the top it says, Mary says she can use the fact below to write a power raised to a power with a single base and power. Okay, so she's saying that she knows that 2 to the third raised to the second equals 2 to the third times 2 to the third. Well, if that's the case, how would we rewrite this? Remember, if we expanded it, it'd be 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 6th power. Well, 3 plus 3 is 6. So we know that splitting these up and adding these together comes up to 6. What else comes up to 6? Well, if we take this exponent 3 and multiply it by this exponent 2, we get 2 to the 6th. So let's take that kind of thought process right here with 3 squared to the second, all of it raised to the second power. Okay, well, what we can do is multiply these two exponents together, and we leave our same base. That comes to 3 to the fourth. And we can prove this out because we can take 3, we'll go 3 times 3, and we're going to raise this. That's supposed to be a parentheses, by the way. I'm going to raise this to the second power. Well, 3 times 3 is what? 9. And now we're going to raise that product to the second power. 9 squared is 81. Okay, 81. Well, I'll go ahead and switch colors for you here. 3 to the fourth, we have 3 times 3 times 3 times 3. Well, 3 times 3 is 9, times 3 is 27, and 27 times 3 just so happens to be 81. Okay, 81. So that's part D. When you have an exponent outside of an integer raised to an exponent, you can multiply the two exponents together to rewrite it this way, as in 3 to the fourth. Now on E, we've already talked about a to the 0 equals 1, anything to the 0 equals 1. And now we're learning that a to a negative integer means that we are going to invert that number and turn the exponent positive. So to give you a better example of this, let's say we had 2 to the negative fifth. Right? 2 to the negative fifth. Well, what we do with that is we are then going to invert this, makes it 1/2, because essentially this is 2 over 1. So we turn it, flip it upside down, invert it, 1 over 2 to the fifth. Okay, 1 over 2 to the fifth. So we invert it, and then we make the sign on it positive, and then you would carry this out, which would be 1 to the fourth, 1 to the eighth, 1 to the 16th, 1/32. Okay, so if you raise this to the fifth power, it would be 1/32. Okay, I know I went through this fast, uh, but there was a lot of stuff. There's a lot of stuff here on these 3 pages. I've done part A of 1. I want you to do the rest of these, B and C, as well as 2 and 3. Same here, B and C, 2 and 3, B and C, 2 and 3. B and C 2 and 3, and then just be aware of this last part. See if you can rewrite this equation. So there's a lot going on here. We can get a lot of practice done in the classroom, so come ready with questions. Make sure you've taken notes on this. Go back, rewatch it, take more notes, whatever you need to do, and then come to class with questions. Again, our ACEs for this are 2 through 25 and 70 through 71. Looking forward to the discussions we'll be having in class.